Delighted to be here this morning with every one of you. So if you've attended some of my previous sessions, you know this is where I usually start with the shameful confessions, and so you already know I was a Flash developer, so that's okay. We got that out of the way. I thought to skip Greg of one such confession today, but I think it's fair to say he was a Facebook ads developer, so you can hate him as much as you want.
Only for a few months. It was just a few months. It was a lapse.
So I had even more shameful confessions for today. But while we were talking to some friends on Monday during the community event, it was brought up that when we're together, we're just standing maybe closer like this. This is how we look like. Apparently, I'm the fat one. I mean, I don't know why. And he's the short one. That's probably because he's the smart one, right? So I didn't think too much about it in the beginning. But you probably know the story of Asterix and Obelix, right? It's year 50 before Christ, and there's just, like, the whole goal is conquered by the Roman Empire, and there's just one little small village of indomitable Gauls that, against all odds, resist the Roman conqueror. So that's often how frontends at Liferay felt for a while, right? Fighting that back-end empire with all their tools, all their power, and trying to make something out of it, right? So what little the Romans knew it was that the Gauls had a secret potion. They had something that made them very, very, very strong. So here today, we want to say that frontend in the last years, frontend development has been gaining some of those powers. We have some secret potions that we're starting to use to become stronger. So before we move any further, I want to see some quick show of hands. How many of you here consider yourselves front-end developers? Okay, it's more than expected. The rest of you, please, if you could stand up and just leave the room. This is not for you. There's no magic potion for you, right?
Yeah.
Okay. What are you waiting for? Okay. I think we can share some of it with you today. And so there's a recent trend that you might have heard, which is called Micro Frontends. And as Greg likes to say, Micro Frontends are not frontends for ants. This is a very dark joke. So when you're thinking about software development in general, and this might be really quick because Kristen already touched on these subjects, you might think about software divided into two different, maybe, technologies, right? Backend and frontend, as Romans and Gauls were. So you can think about different set of technologies, like a set of technologies that help you build really robust, scalable, safe, and secure software, right? And then you have another set of technologies that you can use to build, well, the backend, right? But if you, as applications grew more complex over time, it was just natural that backends would need to split their applications, right? Make them simpler to understand, to evolve, and to maintain. So fast forward some years now, like maybe 10 years, and the question was, what took us so long to apply these same concepts on the front end? Why we stayed with big, large front-end applications that put together all these front-end different systems, all these back-end systems, instead of splitting them into smaller, more manageable parts. So this is what some people are already calling today micro frontends. But you can take this some step further, and some people are also doing that. So rather than thinking of different components that you put together, why don't we take this all the way and slice our whole business, our whole application into completely vertical slices. So rather than separating by technologies, we separate by concerns, by domains. So we can split our business into different teams, different areas that are responsible for one thing and one thing only, liberating them from the constraints of having to work with each other. If you think about what the user sees, which is at the end what matters, and as you've already been seeing, we don't care so much about nice diagrams as we care about users and developers. But this is what a user would see. And it might be unified, but the goal is that it might be good. And you can see different micro frontends here put together, assembled as components if you think of them as components. But if you think of them as applications, there's other ways you can assemble them. So you can have different applications completely independent from each other, and then just having some very, very, very thin layer that interconnects each other. So one application, one micro frontend can just offload work to another when it's done, and so on and so on. So you keep those separation of concerns very, very isolated. So the question is, how did we get here? And maybe, Greg, do you have an idea?
Well, if you come from the Roman Empire, you might have a sneaking suspicion that we got here because some front-end developer wanted to find a way to get React into the product. Or maybe their pet hobby was using Angular. They just wanted to use the latest, shiniest new toy. But I think, as Kristen was pointing out in her keynote, we've actually been doing this for a long time, splitting our complex problems into a smaller set of sub-problems that are actually tractable for us to deal with. And so if we look back over time, all the way back to the 70s and perhaps earlier, we have a long history of modular architectures, starting in the 70s with modular design patterns, where a lot of the vocabulary, which is just common currency today, first arose. And these ideas have taken different forms over the years, because fundamentally, decomposing large problems into simpler subproblems is not actually easy. Making things simple is hard, which is why you wind up with disasters like some of the ones we just saw on the screen. So as we move through this timeline towards 2000, and the early 2000s when Liferay first arose, and through more recent developments like microservices and then micro frontends, all of these are part of a long tradition of modularization. And some of the philosophy that first arose in the 70s is still with us today. So let's just look at some of the terminologies. As I said, making things simple is actually hard. So a term like cohesion is familiar to all of us, and maybe we have an intuitive grasp of what it is, but it's not necessarily obvious what makes a cohesive system. I could try to give you a really brief definition, but I think it boils down to grouping like things together to make them more intellectually manageable. Another would be loose coupling. So if we break things into modules, obviously they can't actually serve a function until we connect them to one another. But how do we do that without just reconstructing the monolith all over again? Well, we figured out about 50 years ago that loose coupling was a desirable way to do this because it provided us with the flexibility to make our implementation independent of the interface contract. And so that meant that we could swap implementations, we could evolve them, as long as we respected the interface contract. Another useful principle we found out was composability. This is really the motivating cause here, because we want to break that complex problem down into a simpler series of subproblems. So that means necessarily that we have to be able to orchestrate larger, higher order things out of smaller, simpler subparts. Finally, reusability. Wouldn't it be nice if we could build something once and then have multiple clients use it? And then there is maintainability. If we don't get this right, then we've failed, because it tends to be the case that we don't get things correct the first time we try. We need to build systems that are amenable to change. If you can't change a system, you can't revise your mistakes. So these are the principles that have guided us as we've gone through all these iterations of modular architecture. And that's no different in the case of micro front ends. So let's ask now, when we apply these principles and we go with front ends, what do we get in return? Well, the first thing we get, I hope you've noticed, is that we haven't actually mentioned any specific technologies at this point. We haven't said you have to do it this way, you have to implement it in these terms. So when you move to micro front ends, what you get is freedom to choose the technology.
And another thing you get as you split your big applications into smaller parts is the possibility to produce incremental upgrades. And you've probably heard this story before, where you have a big complex system and you just want to change something, or you want to introduce another framework, you want to replace a legacy system. And it turns out you can't do it. You can't do it because you need to change the whole system together. So what if you could just change a small thing here and there, and then just slowly iterate, because you know that won't affect the whole system. And you can think about this, I like to think about this as how the body replaces their body cells. So if you've heard this story, though it's not technically correct, when one cell dies, another one takes its place, and so on and so on. So after 7 years, your every cell in your body is completely different from the ones you had 7 years ago. And that happened without you even realizing. So how powerful is that mechanism?
Finally, if we break our software up into smaller modules, each module in itself should be simpler. So think what that enables for you in terms of onboarding new people, where they can start working on something and contributing to it without having to understand the totality of the system.
When you put all those things together, what you find out is that you have the capability to actually make those things deploy independently. So if you're thinking about teams, now you have the option to have teams iterate really quickly and deploy independently from others that need more time, need longer release cycles, for example.
And when teams can be autonomous and make their own decisions, that means they can optimize in a way that is adapted to their specific context. They can pick their appetite for innovation, for risk-taking, and make a suitable choice.
Yeah, and the key here is when teams become more and more autonomous, that means that your organization starts being more scalable, more flexible. And by scalability means that you can scale your teams, you can scale your organizations to adapt to a never-changing ecosystem or environment that might put your business in danger. So if you have freedom to scale and to adapt, you're more likely to survive the future. So this is more or less just theory, right? Sounds great on paper, looks even better on screen, on a big screen. But if this is such a magic potion and it works so well, you're probably wondering, like, how come we've never heard about this before? Some of you might, but some of you haven't. So why? Why do you think, why they don't have?
Let's look at some examples.
Okay, so they're actually successful organizations bringing Micro Frontends to scale.
Yeah, so the first one we want to look at is Spotify. This is the Spotify desktop app. It's an Electron app, which basically means a downloadable binary that consists of the Chromium web browser engine and a set of bundled front-end resources, markup, scripts, styles. So they decided to divide their application up into sections that would be owned by different teams responsible for drawing different parts of the user interface. And these are all assembled using iframes. And each team is completely independent and can choose whatever technology stack it wishes to deliver that functionality. And they were operating under some pretty interesting design constraints that aren't familiar to people who necessarily work on the web, because they could literally let the teams do anything they wanted, and they didn't have to worry about download times or redundancy or anything like that. The sidebar could be built in Ember, the search could be built using Angular, the main panel could be built using React, or whatever they wanted. And it's worked quite well for them, and they have a performant, delightful user experience.
Another recent example is The Zone. And The Zone is an online streaming company that specializes in sports events. So they stream live sports events to millions of subscribers at the same time. And the way they decided to approach their problem was radically different. So rather than thinking about components and how to compose them together, they actually use domain-driven development very strictly to decompose their organization into different domains, so that they could give to different teams, so that they would take care of the whole life cycle of that thing. So for example, they would put together a landing team. Landing team was responsible to create one single application, one SPA, if you will, that would take first comer, and it would provide all the information they needed to actually become a subscriber. When that role was fulfilled, they would just transfer control to another application, the login application that would get the information they needed from the user. That team would then pass on all the information of the user to the catalog team or the catalog application, and so on until the user got through the whole user journey. And the only thing these applications had in common was a very thin layer they called the bootstrap that was the first thing you would load when you go to the page, and it takes care of making sure that there's just one and only one application running at any given moment. And then you just transfer control to one to another, keeping the organization very, very, very split and isolated.
So the third and final example we want to look at is the IKEA mobile website. So much like Spotify, they wanted different teams to own different parts of the UI, but their operating constraints were totally different. Because they were on mobile, performance was absolutely critical, and they had to minimize redundancy and latency at all costs. So they're using edge side includes to effectively parallelize a bunch of sub-requests on the back end that pull in fragments, and then it's all assembled together and given to the client. They make it fast by relying very heavily on caching for content that doesn't change frequently, and then they'll use client-side includes for stuff that's personalized and has to be unique to each user. So hopefully what's clear by having looked at even only those 3 examples is that there is a radically diverse panorama that you can choose from when it comes to implementing micro front ends. It's an architectural pattern. It's not a prescription of how you should do things or what technologies you should use. And so the question that I always like to ask when somebody tries to sell me something like this is like, is the juice worth the squeeze?
You do that question every time.
I do it all the time. It's because I might be thirsty, but it doesn't mean I want to walk 500 miles to get a glass of orange juice. So all of these things, they might sound good on paper, but they have trade-offs involved, don't they?
Of course, like everything, there's pros and cons to every decision in life. So as you're splitting your applications, you end up with smaller, simpler modules. They're easier to understand, to reason with, and they're easier to change. But on the other hand, now you have a more complex dependency graph. It's harder to understand the whole and how everything interacts with each other. So the whole is harder to understand than the parts.
If you are a Roman soldier, this probably sounds familiar, right? You're probably thinking like, we've been here before. That's a familiar trade-off. Here's another one that might seem familiar to you, and that is that when you isolate things, sounds really great, right? Your modules are resilient, nobody can break your stuff, but you have to figure out how to integrate, and the more you isolate, the higher the cost of integration is going to become.
And finally, as teams grow in autonomy, and they also grow more siloed and independent from each other, and that inevitably leads to duplication. And duplication can be of people, of work, of resources, components, whatever you want. And it's not necessarily a bad thing, but of course, as an organization, you're always looking to save money and save costs, right? And you might not want every team having to do the same things over and over and over, just because by some architectural decision, you're just preventing them from sharing anything, right? So, and you probably also don't want different teams just throwing different versions of the same component or of the same library on the same page at the same time, making your users suffer the consequences of your technical decisions. So, is the juice worth the squeeze?
Unfortunately, the answer is a familiar one, and it is that it depends. And I think one of the reasons why the decision seems so difficult to make is because maybe we think about it in terms that are too black and white. But that's not the choice. The choice is not between a totally pure micro front-end architecture on one extreme, where teams have total, almost chaotic levels of independence and there's no real overarching orchestration and coordination. And then on the other end of the spectrum, monolith and everything all in one place. The reality is that it's always possible to view this kind of situation as a spectrum. And often when you've got a spectrum, the optimal place to be is not going to be at those extremes. Look somewhere in the middle to see if there's a sensible place to locate yourself. And so if we go back to one of our earlier diagrams and we talk about a product that's cut into vertical slices, this is a kind of pure theoretical view of what the architecture is like. But the reality is there will always be some kind of horizontal substrate that has to tie it all together. And for me, this is the key slide in the entire presentation. I want you to keep this in your mind as we move forward, because this is where Liferay DXP comes in and provides that horizontal substrate that's going to put it all together. So after some minutes here discussing theory, now how does Liferay help you deliver successful micro front-end solutions to your clients? And we've been doing this for a while, right? So we've been amassing a huge variety of tools that we put at your disposal to make you successful. So we'll be covering from very high-level abstractions that help you or help your developers reason with complex problems with this, because we've provided those from them. And we also have, on the other side of the spectrum, very low-level primitives that help you actually tinker around with very low-level details whenever those high-level abstractions don't serve you well. Another way to think about what we provide is between build time and runtime. We have things that help you assemble or put together your applications or your software and prepare it for perfect delivery. And on the other side, we make sure that on runtime, those are properly served and your applications remain performant no matter what. Here, I think we can take all a moment of pause to recognize the first ever micro front-end technology invented. So if you're here, if you've been with Liferay long enough, congratulations.
you're actually front-end developers and you've been doing micro frontends for so long, so you're at the avant-garde of front-end development. So you can give yourself an applause if you wish. So while portlets have been always a solid foundation for you to build frontends, to actually decompose your problems, have different teams build different applications that then you could compose, reuse, and configure in different ways, right? And good news is that I was really happy to hear Neil got a very nice crowd yesterday talking about Portlet 3. So Portlet spec is not dead, it's still evolving, and the good news is that it's learning from what are the new trends in the front end to add new features to the specs. For example, now you can listen on the client to changes on other modules, so you can actually react and create real interactive experiences without having to go back and forth to the server every time.
So another key concern that you're going to have to address, no matter which point you place yourself on the spectrum, is the question of routing. So a few years ago, we came out with Center.js, which is our answer to having single-page application-style navigation without having to rewrite your entire app. The idea here being that when the user navigates from one view to another, we don't actually do a full page reload. We just retrieve the markup from the server, evaluate the resources that are new and specific to that page, and we don't redundantly download or reevaluate any of the things that we already had and that were common to both pages. However, this is great for what it is, and you get it basically for free because it can be the difference between downloading a megabyte of front-end resources on every page and only a handful of kilobytes. So that's great. However, time doesn't stand still. Since 2014, when Senna came out, single-page applications have become even more predominant in the ecosystem, and the usage of routers like React Router and the Vue or the Angular router is quite common now. So we've been experimenting with ways to integrate these routers such that you can architect your application in terms of a slice of it being built as a single-page application managed by its own third-party router, and have that seamlessly integrated with Senna so that it can still be responsible for the overall orchestration of movement between different parts of your application.
Another aspect we're exploring, and it's become a very common trend in the front end in the last years, is a change on how we approach building applications. So rather than stitching together components, there's this concept of moving your application state to some higher authority up there. So rather than having to understand all the interactions you have between all components, you just have one single source of truth, call it state. If you've heard about Redux, similar architectures, they just keep all the state somewhere else in a single high-level source of truth that then just boils down to every component. So we're looking at ways that we can provide some facilities to make it easier for you to describe your application somewhere and then have, no matter what you're using, no matter the framework you're using or how you're composing, that you can actually subscribe to changes on that state and then just get your different parts of the application react in a synchronous way. And as we said, when that's not enough, you've always had very low-level primitives that allow you to just take two isolated, loosely coupled components and just stitch them together through APIs. Like we have the fire on once event emitter that's always been available, where you can just send an event, providing a payload, and everyone that's listening can just react to that. And Portlet 3 has the equivalent APIs for it, so you can just pick which one you want.
So obviously, coordinating data flow on the client side is important, and it's a big part of what we do. But we couldn't do anything without getting data from the server. And that's why the recent investments we've made in exposing REST endpoints and the GraphQL schema of a Liferay instance is so helpful in this context of micro frontends. So as an example, because they're both standard, both REST and GraphQL, there's this huge ecosystem of libraries and tooling that you can access once you've got your data. And so what we're seeing here on this slide is a GraphQL ID that allows people to experiment with writing GraphQL queries and getting the results. But it's not just that kind of tooling, it's also the client libraries. One example would be the Apollo client, which has adapters for Vue and Ember and React and most of the popular front-end frameworks that enable you to get this data and use it once you've got your micro frontend in place.
And as we move to talk about libraries, one key ingredient that you probably have heard that's talking about in the past few years is what we're calling the Liferay JS Toolkit. The Liferay JS Toolkit is the secret ingredient that's allowing frontends to leverage the tools they know to be stronger and to be more productive. So if you attended yesterday's frontend talk by Carlos and Rodolfo, you probably heard about this already. So one of the new features we introduced was Adapt. And what Adapt does is that it allows you to take it allows you to use standard industry de facto tooling for the most common frameworks. So take Vue CLI, or you have a React application created by Create React App, just pure standard React, nothing to know. It knows nothing about Liferay. Same with Angular CLI, same application, nothing. It knows nothing about Liferay. With very few commands, so it's actually just install the generator, run the adapt command. It will transform your React application into something that you can deploy to Liferay. And the beauty here is that apparently standard React app that knows nothing about Liferay can be automatically, seamlessly integrated into the whole ecosystem, into the whole set of features that DXP provide. Here you saw how a React application just appeared in the fragment panel. You could just add it to a content page and then just have it working with just few clicks and very fast.
So when that's not enough, when merely adapting and adopting a project isn't enough, you can start from scratch with the Liferay JS Toolkit as well. This effectively gives you a blank canvas. And once you're in there, you can import any package you want from the NPM ecosystem. So the example we're seeing here is the Apollo client. You just import like you would in any JavaScript environment. Additionally, we recently added this year the ability to load non-JS resources. And so that means you can require a Sass-style sheet or a CSS-style sheet in a way that would be familiar to you if you've used a product like Webpack, which you probably have if you're a front-ender. So it's probably worth pausing here for a moment to talk about how our bundler is different from a bundler like Webpack or Rollup or Parcel. Those bundlers operate on the assumption that they can statically analyze the parts of the app that will be accessible to the user at any given time. That means they can create an aggregate bundle of all the resources that will be needed because they know what could potentially be needed at any given point in time. In the context of Liferay DXP, you don't necessarily have that luxury because it's a much more dynamic environment. People can change pages at any time. And so the only time we can really construct a bundle is at runtime. So what our bundler does is actually divide this problem into two phases. The first phase is preparing the resources, but not bundling them together yet. We prepare them in such a way that they can be bundled dynamically at runtime. And then when the user navigates from view to view, we will construct an optimal packet just for that navigation that will download only the resources necessary to show that result without any redundancy. But as we alluded to earlier, you probably don't want to be in this Wild West chaos where teams can just willy-nilly download their own version of React and you might have 3 versions of it on the page at the same time. This is a problem that we've had to deal with internally as we move to React. We basically want all teams relying on a shared version of the library. So we've taught the bundler to be configurable so that you can construct, as we have done, if you want, an OSGI module that contains a shared set of common dependencies that you want to rely on. And in our case, it's the latest version of React and a carefully vetted and small subset of other dependencies. And then, as we build micro front ends in different parts of the company, all of those can leverage the same version of React. And the bundle will ensure that they all rely on the same one. Another thing that we did is we leveraged some performance improvements that were necessary. So the way things used to work with our bundler was that the dependency graph of all the modules in the app would actually be downloaded as JSON metadata to the client. And the client would do this dynamic resolution at runtime to figure out, okay, what things do I need to bundle together and download now to make this next page work? We moved that resolution to the server earlier this year, which means that you no longer have to download this huge slug of metadata, and the performance improvements have been considerable. And the other thing that we did was, as we've encouraged developers to tap into this broader ecosystem, we found edge cases that we needed to handle, such as the ability to support projects that use circular dependencies. Now, this is a really great example of how having a transversal layer of infrastructure can be helpful, even if you do pursue a micro front-end architecture. And that's because if we make a performance change in the loader, everybody gets that benefit for free without having to do anything. And so we're always on the lookout as an infrastructure team for places in our software ecosystem where we have high leverage and we can deliver an improvement across the board like that.
And finally, even if we're infrastructure team and we care about like these pieces of build time and runtime, there's more than infrastructure in a platform. And that's also where we see one of the key benefits of using DXP as a platform for your micro frontend solutions. So it's not just in the infrastructure, but it's also in the already provided out-of-the-box functionality that you can tap in for free if so you will. So one thing we've done lately too is to provide a way for React or Angular front-end, pure front-end applications to define in a declarative way configuration. So you can actually have a pure React app and tap into the DXP system settings very easily. So here you have an example on how you have a React app that's defining a system setting for the color of points. So if you remember our same React application from before, just by adding that simple configuration JSON file and just deploying that to DXP, you would automatically get a new system setting category with the name of your application that you can configure. So an admin can go there depending on your brand or of your organization, just change something and automatically see that reflected everywhere in your app. So we've turned somehow static React apps into something that's dynamic and very, very, very well integrated into the system. And another configuration you can add is by instance. So imagine here how you want to use the same application, but now you want to have it display different things depending on the context or depending on different business logic you have. So here we're adding a content key setting that allows you to use CMS or CRM, anything you want from your system. So here you have the same application. Is this the same application? Yeah. Okay, yeah, so now if you add the application here, now as you can see now it needs to be configured because now we've added this configuration by default. So integrated in the page editor now, you get this configuration where you can pick from your CMS, from your web content management system, different keys to show different contents that some editor, some other part of your organization already provided for you. So this is another great example on how pure frontend can provide a very configurable, reusable application that you can then deliver to your customers. So after all this, and after spilling our secrets to all these Romans, what do we do now, Greg?
Well, you know, when I was thinking about this, I heard about micro frontends for the first time, and it was another one of those JS fatigue things. It's like, oh my goodness, I've got to learn another thing. How are we going to be ready for this? Are we going to be able to adapt? And it was a great relief when I actually looked at what we'd been doing for years now to see that we'd actually been doing it all along. And what we need to do as we move forward is to keep doing it. And so what is it about Liferay DXP that equips us to be the best platform for choosing a place along that micro front-end spectrum? Well, I think it boils down to 3 strengths that we have. And the first one is that we recognize the value of balance. We're not advocating to go all in for a totally pure micro front-end architecture, nor are we saying that you should just hoe down and go deep on the monolith. But we believe that there is definite value to be had in finding an optimal compromise position and having something that cuts across the entire layer of the stack.
And as you strive to find that right balance where you want to sit or where you need to actually sit, we want to provide a platform that's flexible enough so that it won't break under the constraints of your organizations and that still will provide value and enough leverage and pull for you to be successful.
And why are we good at this? Well, it's because of the word platform. Like, this is the word that's in our DNA. Everything we do is about building a stable basis on which other people can build things that we haven't possibly even imagined yet. And that, for me, is what's so exciting about building a platform.
Yeah, and so we hope to see you all go back to your work, and hopefully we'll see you back here next year with hopefully some more front ends. So please share it with them. We want to grow our community 100x, and we know front ends are out there. So just please bring them back next year so we can have nice dinner sharing our stories about how you made successful micro front-end solutions out there so we can keep improving. So,
and maybe you'll even tell us about the nano front-ends that you've been building. Remember, you heard nano front-ends here first, okay? 2019, nano front-ends.
Thank you very much.